Hello, this is Mr. Murphy, and I'm going to do a review sheet for you guys here that you can follow along with that hopefully goes over a decent amount of the problems that we learned here in Chapter 8. Obviously, there are additional practice problems within, worksheets 3, 4, 5, or, problems that your classroom teachers might have given you guys. But this is as a broad overview of the types of problems that we've seen throughout the chapter. So first couple are just simplifying our radicals. So if we're writing these in simplified radical form, if I'm looking at problem number 1, I'm seeing this rad 6 and rad 18. I know that 6 and 18 can be simplified, so we can rewrite this as 4 over rad 3. We can put those back together, right? At the same time, I'm just going to simplify the rad 75. So that's going to be 25 times 3, so we can write that as 5 rad 3, right? At this point, I would say rationalize the denominator with both of these. So I think without even writing this in, I think hopefully we can all follow along. This is going to be 4 rad 3 over 3 minus, that's going to be 4 rad 3 over, that would be 15, right? In order to go further with this, we need to get a common denominator, right? So we need to multiply our left side there, that left term, by 5. So we are going to have 20 rad 3 minus, I'll put it all together here, minus 4 rad 3 all over 15. Because these are both rad 3s, we can put them together, and we can say that this is going to be 16 rad 3 over 15. The 16 and the 15 don't simplify, so that's our final answer for that one. For number 2, if we're looking at it, we've got the 6th root of 256 in our denominator. So what we want to do with this, I think the easiest way to do it is rewrite the 256 with as small base as possible. So whether you're using your table still to kind of reference, I know that 256 is the same as saying 4 to the 4th, right? If I now write that to the 1/6 power, that's the same as the 6th root. So if I simplify that, I have 4 over 4 to the 4/6, which I can simplify to the 2/3, right? So if I just kind of rewrite this down here, we got 4 over 4 to the 2/3 power. If I want to rationalize that, I need to make that an integer there. So what I need to multiply by is 4 to the 1/3 in both our numerator and denominator, right? If I do that, I now have 4 times the cube root of 4 all over, it'd be 4 to the 1st, so just 4 with that. Our 4s are going to cross out nicely and just leave us with cube root of 4. All right, number 3, we got same concept. We got 15 divided by 4th root of 24. So we want to rewrite this breaking down our numbers. So we got 15 over 4th root. If I'm thinking about numbers that go into that, this would be what? We could say 8 times 3. That would be one way to rewrite 24. I can now take the 8 and the 3 and rewrite these with as small a base as possible. Right? So this is going to be equivalent to 15 over the 4th root of 2 to the 3rd times 3. Right? So if we're trying to figure out how to rationalize this, how many more 2's and how many more 3's do we need? I'm going to try and keep this one in radical form just to show you a different way of looking at it. How many more 2's and 3's do we need to simplify this? So we know we need to multiply by a 4th root over a 4th root, right? So if I have 2 to the 3rd, I need to get that to be a 2 to the 4th. So I need one additional 2 to be multiplied, right? We have 3 to the 1st. That needs to become a 3 to the 4th. So I need to multiply that by 3 to the 3rd, right? So when we simplify that, in our denominator, just to kind of show you what that's going to look like first, it's going to be the 4th root of 2 to the 4th times 3 to the 4th, right? That was the goal. We wanted to make it so that the root matched up with what the exponents were on the inside. So this is going to be times, or in our numerator, we're going to have 15 times 4th root of 2 times what? That would be 2 times the 27. So we're going to have 54 in that spot, right? So if we continue simplifying this, we got 15 times the 4th root of 54, and that's going to be all over just 2 times 3. From here, I can take this one step further. I can simplify the 15 and the 3 and just make that a 5. So our final answer is going to be 5 times, that's going to be what? It's going to be the 4th root of 54 all over 2. All right, with number 4, we have fractions within fractions, right? We got a complex fraction here. So I think the easiest way to do this, what most of you guys have been doing in your classes, is simplifying the numerator by itself and then simplifying the denominator, right? So if we do that, if we multiply within our numerator, we can say this is going to be what? 5 times 2 rad 3 plus 1 all over 2 rad 3. And in our denominator, we're going to have 3 rad 3 minus 1 all over rad 3. Right? So I can obviously simplify the 5 times 2. So I've got 10 rad 3 plus 1 over 2 rad 3. And then I'm just going to all in one step multiply by the reciprocal here. This is our keep, change, flip. So times rad 3 over 3 rad 3 minus 1. At this point, I can simplify a little bit. I can cross out these rad 3's. Right? So now when I multiply through, I've got 10 rad 3 plus 1 over, that's going to be, the 2 is going to distribute through. So we're going to have 6 rad 3 minus 2. All right, at this point, we have a radical in our denominator, but we also have a binomial. So this is where we need to multiply by the conjugate, right? So multiplying by the conjugate, we're going to multiply by 6 rad 3 plus 2 over 6 rad 3 plus 2. All right, if we simplify that, so we're going to have to FOIL both in our numerator and our denominator, we are going to get what? We're going to get 60 times 3, right, plus 20 rad 3 plus 6 rad 3 plus 2. Right, that's just FOILing that out. Then in our denominator, it's really just first term squared, second term squared, right? So we're going to get 36 times 3, and that's just going to be minus 4. From here, we've got the radical out of our denominator. We just need to clean this up a little bit. So if we simplify, we are at what? We're going to be at 180 plus, say, 26 rad 3 plus 2. All over 36 times 3, we're going to be at what? We're going to be at 108 minus 4, right? So we get down to, we're at 182 plus 26 rad 3 all over 104. I think, now I did this out before, but 26 actually goes in evenly to all of these. So we take a 26 out of everything, and we're going to end up with 7 plus rad 3 over 4. So that's obviously a pretty good problem there that had a lot going on within it in terms of stuff that we've done this chapter. If we flip the page, number 5, this is one that you would have seen in Mr. Scott's video from earlier in the week or last week. You have a trinomial with your radicals in the denominator. So we want to multiply by the conjugate, but we need to group our first 2 terms before we do this. So we group those first 2, kind of put parentheses around that. So when we're multiplying by our conjugate, it's going to be rad 2 plus rad 5 minus rad 7. So we got rad 2 plus rad 5 minus rad 7. All right, if we now just multiply this through. Up top, it's nice because we're just multiplying by 1. So that's just going to remain as our rad 2 plus rad 5 minus rad 7. Right? In our denominator, what are we going to end up with? We're going to have to FOIL that first part. So we're going to have 2 plus, that's going to be what? 2 rad 10 plus 5. And then it's going to be minus 7 at the end there. So if we kind of simplify this out a little bit, our numerator just stays as is for the moment. If we simplify our denominator, we see that we got the 7 minus 7, so we're just at 2 rad 10. Right? If we continue on with this, what do we need to multiply by? We need to multiply again by the conjugate, and we get rad 10 over rad 10. Simplify that out, we got rad 20 plus rad 50 minus rad 70 over 20. Right? We just need to simplify the rad 20 and the rad 50, and we end up with 2 rad 5 plus 5 rad 2 minus rad 70 over 20. So we'll see who's paying attention. Where have we seen this before? Right? This was a exit slip problem. So this is something that we should all be, hopefully good with at this point. This is the second time you've seen it. Now you've seen it with the work done out for it. But hopefully when you guys were doing your exit slip, we all got to that same answer there. All right, last one. This is talking about stating the domain in interval notation and then solving this out for x. So when we are stating our domain, so maybe if we kind of just do that first, what do we need? We need our 3x to be greater than or equal to 0, right? We need 2x minus 1 to be greater than or equal to 0. And then with our last one, we need 2x minus 1 just to be greater than 0. So we can almost forget about the 2x minus 1 being greater than or equal to 0. Right? So if we're solving these, we know that we got x has to be greater than or equal to 0. We can say x has to be greater than or equal to 1/2, and then x has to be greater than 1/2. So if we're putting all of these things together, our domain the overlap of all three of those parts is x has to be greater than 1/2. So our domain is going to be from 1/2 to infinity. So we can kind of just keep that there for right now. After we solve it, we're going to just make sure that our answers fit into our domain. All right, so with this particular one, you might remember from Mr. McGivney's videos that we're trying to get an LCD for this, right? Once we get that common denominator, we can just get rid of it as we've seen before. So I can kind of take this entire thing, and if I just multiply everything by square root of 2x minus 1, that's going to kind of work itself out here. So when I'm doing that, the square root of 2x minus 1 times the square root of 3x, we're going to end up with the square root of 6x squared minus 3x. Right, got to distribute that through. 2x minus 1 times 2x minus 1, square root of those is just going to be plus 2x minus 1, and that's going to equal the square root of 2x minus 1 is going to cross out with our right side of the equation, so we're going to be left with just 5 in that case. All right, so now from Mr. Dooley's lesson, once we have no fractions, what you guys should remember is you want to isolate the radical. So we got to move everything to the other side before we square it. It's going to make our lives a lot easier. So we got square root of 6x squared minus 3x equals, when we add everything over, we're going to have 6, or add or subtract everything over, we're going to have 6 minus 2x. So at this point, this is where we want to take both sides and square them. So with our radical, obviously it works out just really nicely. That just cancels out. So we get 6x squared minus 3x. On our right side, we need to make sure that we're FOILing this. So we're going to have 36. That's going to be what? Minus 24x plus 4x squared. At this point, we've got no radicals. We just want to bring everything to the same side of the equation and factor this. So if we bring everything to our left side, we're going to have 2x squared. We're going to have, let's see, plus 24x, so plus 21x minus 36 equals 0. So at this point, this is one where if you're good at guess and check, we can do that. If you are not good at guess and check, you would want to do split in the middle term with this. If we know that we need to get back to a 2x squared, we need a 2x and an x there, right? With this one, if we're thinking about our factors of 36 that work, I think when I did this out, I think 3 and 12 are our numbers, so it's going to actually be 2x minus 3 and x plus 12. So you can kind of just quickly in your head FOIL that back to see that's going to work out. And again, if you're not good at guess and check, no problem just doing split in the middle term with that. Our answer now, using our zero product property here, we got x equals 3/2, x equals negative 12. This is where you need to be careful. You need to go back and think about what we said our domain was here, right? So the negative 12 is not in our domain. We get the x equals 3/2. Obviously on something like this, you would want to plug in the 3/2 to check your work. Just make sure that it works out and it's not an extraneous solution. So you can check that out, but it does end up working. So that is definitely not a full review of everything. As you can, tell, it's just 6 problems that we did there. Had a little bit of most of what we covered, but there's more work within, worksheets 3, 4, 5. If you need additional practice problems, I'm sure you can reach out to your classroom teachers and they can provide those to you.